So, the four methods of forecasting the weather. Well, given that we know what is happening now with the weather, you know where the high and low pressure systems are, you know where it's raining or not raining right now, snowing, not snowing, what the wind is. If you know where everything is now, how do you forecast where things will go, what things will be like in the future, be it tomorrow or next week and such? Well, very broadly speaking, there are four approaches you can use, and you can combine these as needed. Number one is pretty easy. You just say, well, whatever's happening today, it'll keep on happening tomorrow. So if you have a rainy day, say you look outside, it's cloudy with some fog, maybe a little rain, you say, well, tomorrow be cloudy with a little fog, a little rain. When in doubt, this is called persistence. And it's not entirely just a punt. There's a reason for doing this, that high and low pressure systems can take some time to work their way across an area. So if you have one sunny, hot day in the summertime, the next day may also be sunny and hot. If a big area of high pressure is the reason for this kind of weather, it'll take some time for that high pressure to go over your area and then move on somewhere else or to dissolve in place. It takes some time, more than one day. And so a given broad weather feature can bring more than one day of weather, and that's how this persistence thing can work. We've seen this in the winter when you have the long cold outbreak, where you have 4 or 5 days a week of really cold temperatures, just day after day. It's 30 below, 40 below, maybe 50 below, and it just doesn't seem to end. That's because the same weather system is bringing this to you. This is called persistence. So the weather we have today will continue for us tomorrow. By the way, this works great in the tropics. If you're in Hawaii or somewhere down there, in the lower latitudes where they don't tend to have cold fronts and things like this, the weather can be very repetitive down there. Up in the higher latitudes where we are, it can work sometimes in the short term, but it tends to break down. Let's say it's June and the high on a given day is 75 degrees in the interior of Alaska. You can say, well, tomorrow, high around 75. You might be right. But you can't do this forever, because in 6 months it will be December and it ain't going to be no high of 75. It might be 45 below. So persistence can be a near-term tool, a starting point. If we don't have a reason for change on the weather maps, then say tomorrow will be a lot like today. Okay, method one, persistence. Method two is climatology, or what does the long-term weather record indicate is normal for this time of year? Let's say that it's June and the high is 75 degrees and we get a phone call, somebody wants to know the forecast in Fairbanks for January 15th of the next year. Well, you can't go with persistence because it's not going to be 75 above on January 15th. But you could think of, well, what's normal for January 15th? What do the weather records indicate is a likely outcome? Given that we can't look on the weather map or on the satellite picture and see a given storm somewhere now in June and say, well, but by January it will have gone around the Earth 20 times and we'll be here. The cards will be totally reshuffled as far as identifying specific features goes on the weather map. We can't rely on that. Persistence will break down. But what would be normal? Say in January, middle of January in Fairbanks, normal high is around 0, normal low maybe 15 to 20 below. Of course, there's a lot of spread with that. It could be 40 below, it could be up to around freezing. But if you boil everything down to normal, excuse me, and you go with climatology, with the long-term records, then you have a high around 0, low in the teens, 15 to 20 below for Fairbanks. For a 6-month forecast, that might be about all you can do. So the first two methods rely on things that actually are based in where we are now and in the weather records. We're not really forecasting in the sense of, well, there's a front over here that's moving over there. Just persistence is looking at what there is now, doing it again, and climatology is consulting the record books and saying, well, that's better than nothing for a guess, and it's better than persistence. Well, method number three would be to use our fancy computer models. These are becoming more and more important, and the role of the human forecaster is to use computer output, to use that intelligently and describe what the computer is depicting and to discern, well, what does this mean for us living day to day in Alaska? Just like a doctor has to use a scalpel, you still need the doctor. The computer models are very useful tools, but the person has to interpret what they're saying, and a problem is there's multiple computer models and they have different answers. And a person needs to weigh these different factors. Everything that you measure about the weather, using the radars, the satellite, the weather balloons that go up, the instruments down at the airport runway, all of that information is fed into a computer simulation of the atmosphere, and then the computer crunches. Computers are great at crunching numbers really fast, and turns the atmosphere into equations, crunches the numbers, and spits out an answer. Says, well, that high pressure that's over here now, well, I say that in 2 days that high will be over here, or it will be over there. A storm will develop over here. That's what the computers say. Multiple computers, they have multiple answers. The human interprets what all of this means and comes up with some kind of answer. It's a good day when many of your computer models are singing the same song. That's helpful. That gives you greater confidence, actually, that they may be onto something that's real. When the computer solutions are spread over a broader area, that takes more discernment to see who might be right and what's wrong. You work with computer models day after day after day. You learn which models make which mistakes. And then you try to improve the models so they make those mistakes less often, so you have to relearn the computer's biases and such. But computer simulations are very important, and getting more so as they get better in the weather business. Okay, so that's method number 3, using our fancy computer simulations of the atmosphere. So persistence, I'll say it again, persistence, and then climatology and computer models. Method number 4, though, is the old human being. There's a phrase out there that I did not make up, but they say that a forecaster in a place who's been forecasting for 20 years is a valuable tool. And that's different from someone who's got 1 year of experience repeated 20 times. But if you've been paying attention, doing more than just keeping a chair warm, paying attention to the weather peculiarities of a given area, you've been living somewhere, working somewhere for years, you learn by experience, by scar tissue, what is likely and not likely to happen. And that kind of experience can be very valuable. In a story here from our office it was the fall of 2004, and a storm was developing in the Bering Sea, and the computer simulations were turning it into a big storm in the next few days. And one of our old veterans at the office said, wow, this looks a lot like the great big storm of 1974. And a couple of our folks hadn't been born in 1974, but this guy was here. He worked that storm in 1974. He remembered it, and he remembered this is what it looked like at this stage in its development. And we took his word pretty seriously because he'd been around the block. He knew the drill. And sure enough, that wound up being a huge storm, and the southern coast of the Seward Peninsula, Nome and that area, Golovin, that stretch really got hammered with the coastal flood. It was the biggest event since 1974, and thankfully they had a seawall in Nome built after and because of the 74 storm, and that protected the town. They had a lot less damage than they would have had without the seawall. But that's invaluable to have someone on the staff who knows the area and knows what the weather is likely or not likely to do at given times of year. And that human experience, that's something the computer models don't have. The human can draw upon past experience in almost an intuitive way. And that seasoning is a useful part of the forecast process. Ta-da! 4.